We have these two positive integers, and they want to know whether their sum is even. I don't want to treat this as an odds and evens question because I want to learn something from this question that I could apply to harder questions. So instead, let's think of it as a divisibility question where the divisor happens to be 2. Now, when the divisor is 2, the remainder is going to be either 0 or 1. Those are the only options. That's why we invented the words odd and even, because in the world of divisibility by 2, there's only two options. Either the remainder is 0, meaning the number is even, or the remainder is 1, meaning the number is odd. Now, in order to know what the remainder is when we divide the sum of these two positive integers by 2, we'd need to know the remainder of each of those integers when divided by 2. Now, we could prove insufficiency for each of these statements on its own just by visualizing what happens when you take, say, an even number with an odd number or an even number with an even number and see that those lead to different answers, and therefore neither of the statements is sufficient on its own. But then when we combine the statements, we do know exactly what the remainder is when we divide each of those unknown integers by 2, and therefore we can answer the question. If neither of the numbers on its own contributes a remainder, meaning the remainder is 0 for each of them on their own, the remainder will still be 0 when we add them together, and therefore the correct answer is C.
If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.